Hello, good evening, everybody. Thank you so much for joining me this evening. And thank you again to our TeachMeet team for hosting the event, and also for our TA team who've invited me to talk to you all this evening. And thank you most of all to you who are giving up some very precious evening time, I'm sure, getting towards the end of term, to come and learn a little bit more about adaptive teaching in primary maths. So I'm always very, very privileged to be asked along to teach, to talk to groups of TAs. So thank you so much for giving up your time, and hopefully you will leave this evening session empowered to support your children and with a little bit more confidence going forward in maths. So today's session is about empowering every learner and adaptive teaching. Some of you will maybe more familiar than others on the term adaptive teaching. It's something that is very much used a lot at the moment in education, but in education, as we know, things come and go, and it can sometimes be difficult to know exactly what they mean. So hopefully we'll be able to start today by making that that little bit clearer. So a little bit about me. I have got over 20 years experience in the classroom teaching, predominantly Key Stage 2, and I've also been Maths lead and Key Stage 2 lead in that time as well. And I've been in the classroom as recently as last academic year. So this academic year actually came out of the classroom in January. So very recent experience. But I've also worked at Twinkl for the last 4 years on the maths team in various roles. And I'm now one of our team of educational content leads. So what are we going to look at this evening then? So first of all, as I mentioned before, we're going to look specifically at adaptive teaching. We're going to look at the similarities and differences between what I'm going to refer to as traditional differentiation and adaptive teaching, and why those differences matter. I'm also going to then look at key recommendations and guidance from the Educational Endowment Foundation around scaffolding in primary maths. We're going to talk about what effective scaffolding looks like, how we provide the right support at the right time. Again, that's one of those phrases we're hearing quite a lot in education at the moment. Ways to encourage pupils to be more comfortable when taking risks. That's always a tricky one, but something that's quite important in this area. How being prepared is different from planning, and how we can be realistic about being reactive. We are all very busy. Classrooms are very busy places. Maths is just one of many subjects you're covering, and you're trying to support a huge amount of children. So we need to be realistic about what we can do and be prepared for being able to provide as much support as possible. And then we'll just talk about some really common maths approaches, things that hopefully you're already doing, strategies you might already be using that really support that adaptive teaching approach. So first of all, then, let's have a look at differentiation versus adaptation. And they're not really in competition with each other, but they are two very different approaches. And hopefully you will know what the approach used in your school is, whether you're going down a very traditional differentiation route or whether you started to use adaptive teaching. And if not yet, hopefully this little infographic will help you. And it wouldn't be a maths session without using a maths diagram. So I've got a little Venn diagram here to share with you. So let's have a look then at how these approaches differ. So a traditional differentiation method is about adapting the curriculum itself, or the way something's taught, and the resources that might be used. So you might have a completely different resource for a completely different group of children, for example. Adaptation is about adapting the teaching itself in a way that all learners can access the same content. We know that one size fits all doesn't work, but we also know that at the end of an education phase, a test is taken that is the same for everybody. So we wouldn't be doing our children a good service if we weren't preparing everybody for that, by allowing them to at least access or experience all the content that they need to. Differentiation is about different pupils and groups doing different work. That's where you might have the red team, the red group are doing this, the blue group are doing this, the blue group are doing this, lots of piles before the lesson about who's going to be doing what. Adaptation does allow for different groups of pupils and individuals, but in a different way. It's through the use of scaffolding, and we're going to use that term a lot through today's session, to enable all the pupils to access the same work. So looking at the same thing, but putting scaffolding in place to make sure that everybody's able to access it. Not an easy task. Differentiation in a more traditional sense is focusing on improving accessibility for individuals and groups of pupils. Adaptation is slightly different in that it is focusing on improving accessibility for all pupils. We know that it can be quite damaging to put preconceived labels on groups of children or individual children, and to make sure that we are allowing everybody to experience and learn in a really good way. It improves accessibility for everybody, regardless of groups and individuals. Differentiation is, as I've just said, is often based on preconceived, and I'm using the term ability in inverted commas there, try not to use it really, but preconceived groupings. Maths is huge, and how well a child understands one area of maths can be quite different to another. So certainly we would hope that those groupings would be flexible, but in some cases they are quite static, and that's what we would probably see in a differentiation approach. Adaptation is more about, yes, absolutely, from your input and from observing, and you as TAs hopefully are being included in lesson inputs. I know that's a bit of a seed change over recent years, but being able to see the teacher delivering the lesson using the language they expect to be used, but also for you to be able to observe what's happening in that classroom. That's a really, really key assessment tool to making those flexible groupings. You know, you might think, oh, this child might struggle, but you're watching them, actually they're absolutely fine, but somebody over there might need a little bit of extra scaffold. So that observation time is really, really key. We'll talk a little bit about that later. Differentiation is more planned before the learning happens. So I mentioned about, you know, having those piles of sheets for each group. You might have a post-it on there. This is for a red group today. So before the lesson, it's going to be, this is who's don'ts do what. This is how many photocopies I've done. Whereas adaptation is about actually, like I said, making observations in the lesson and thinking, okay, that child is able to do this, so this is what we're going to do there. That child needs a little bit more scaffold, a little bit more support, so we're going to do this at the time of learning, which can add a little bit of extra pressure, particularly if you're not confident in maths or this specific lesson. It can be really hard to know what to do at the time of learning. So hopefully we'll be able to help you with that as well, with some of the things that we share today. So differentiation is about what different tasks can I give these different groups of pupils so that they can all succeed. And adaptive teaching is more, how can I support pupils so that everyone can succeed in the same task? And we're saying same task, it might not be identical, but the concept will be the same. So it sounds like these two approaches are very much fighting against each other, but at the heart of them, they both have the same key ideas. The ultimate goal is for every child to succeed. That's why we're in education, isn't it? That's why we're teaching. That's what we're doing in our classrooms every day. There is a recognition that a one-size-fits-all approach is not the best one for an inclusive primary classroom. Children are not robots. They are not data. They are individual children with individual needs, and they will be coming to the lesson with a slightly different experience before the lesson, and maybe something's happened at break time. You know, we know that a classroom is a very fluid place, so we have to appreciate that. And we talked about this a little bit already, but knowing your pupils and where they are in their learning journey, and that might be the overarching maths learning journey, it might be this tiny learning journey in this very lesson, but knowing what's happening through that careful observation can be really key. So that's an overview really of differentiation and adaptation. A difficult thing, of course, is, like anything in education, terminology is used and it evolves over time, and one person's understanding of a word might be different to another. So this is my interpretation using some evidence based on differentiation and adaptation, but there is no reason why some schools might take a bit of both, and it's all about making it work for you. But we're going to focus today's session on that right-hand side of that Venn diagram, making sure that we are using adaptive teaching to really act more in the moment and be responsive, being reactive to what's happening in the lesson in front of us. So just briefly want to mention this bit of guidance. So the Education Endowment Foundation produced a guidance report around the deployment of teaching assistants. It is aimed at school leaders, but it's a good read for TAs. And the sentence I would like just to draw your attention to here is, this one. It said that leaders should ensure TAs are prepared to engage in scaffolding practices that support pupils' learning and ability to learn independently. Supporting pupil independence should be a key consideration of TA deployment. And that's really what I want to talk about today. We're going to talk about what that might look like for you in your classroom. So just have a little think, and no need to share any ideas at this point, but what might scaffolding look like in a primary maths lesson? Do you already have a good understanding of what we mean by scaffolding? Are you unsure? What are you seeing happening in your classrooms today? Or is it something that really, that's why you're here, and you want to learn a little bit more about how we might do it? It's just something to think about over the next few slides. So let's break it down a little bit more then. What does effective scaffolding look like? What are we talking about when we're talking about scaffolding? Well, scaffolding, just as in real life, is supposed to be a temporary support. Children can become very reliant on using a particular manipulative, for example, in a maths lesson to help with something. But it's really important that we are aware as educators, but also sharing with the children, that that support is temporary. It's almost a bridge to help us to understand the more abstract. And we'll talk a little bit more later about the concrete-pictorial-abstract approach and how we can use that effectively. But the whole point of a scaffold is to help learners achieve tasks that they aren't yet able to do on their own. And then as their independence and maybe confidence increases, those scaffoldings are gradually removed to enable them to access things more independently. That's our ultimate goal. So in a primary maths classroom, and some of these points, of course, are transferable to other subjects as well, but thinking specifically about maths, encouraging a growth mindset approach is really, really important. Taking risks is hard, and it's hard for adults as well as children. But when you're solving, particularly when doing problem solving, which is there's a real buzz around problem solving at the moment. It's been recognised as something that is an area of development for the curriculum. And having a growth mindset approach, improved resilience, perseverance are really important. So we'll talk a little bit about how we can encourage that sort of approach in our classrooms. Giving learners the opportunity to be independent first. This isn't necessarily very easy, particularly if you're working with a particular child, or you're often working with the same children or child. It can be quite tricky for them not to become overly dependent. And we'll talk about how we can scale that independence on the next couple of slides. But it's about giving them the opportunity first to be independent, and then putting the scaffolds in as and when they're needed. So the support is added or taken away based on initial observations rather than put in place to start with. And it's those observations and those discussions that you're having with the children you're working with are so important. And I think for teachers and TAs, it can be very hard to give value to that time when you're just observing. You can feel like you need to be talking all the time or actively doing something with the children, but the power of observing and listening, as well as questioning and leading discussion, it's really important here. So definitely, I mean, school leaders hopefully are already now valuing that a bit more as observations happen. Definitely something to consider though, having conversations if that isn't quite the case in your setting at the moment. And just briefly mention questions, but we'll talk a little bit more about how we can use questioning, open questions rather than closed questions. So instead of saying things like, well, how many is the answer increased by, being really specific, very, very open-ended questions like, what do you notice, can be really powerful in maths. So we talked a little bit about starting with great independence and then gradually increasing the amount of support. And that is definitely the way we should be going. So a little bit here about what that might look like. And you can see at the top of the triangle, we're looking at really a greater amount of pupil independence. Then we're moving down to adding more input as it's needed. So first of all, give the children the opportunity to have a go. That's the bit that can be really tricky if they don't have a sort of growth mindset approach. Just getting started can be hard. And so it could be that self-scaffolding is a step that you're not quite ready for yet with that child or group of children, but that's okay, because you can put things in place to try to get to that point as well by minimizing the risks. And we'll talk a little bit more about growth mindset later. This self-scaffolding, though, isn't about just leaving the children over there to get on with it. Absolutely observation here, because we know how quickly things can turn. We know within seconds a child can look like they're having a real go, and then frustration can completely take over, and then you've lost them. So having that really close observation at that point to make sure you're ready with that next level of support. Or it could be that the other way, it could be like, actually they've got it, so all they need is a little bit of praise and they're off, and that is great as well. So self scaffolding is sort of the minimum amount of TA input. We then might move on to prompting. So that's where you're going to use really, really open questions that are just a gentle nudge in the right direction. So in a maths lesson, that might look like, is there something in the maths trolley you could use to help you? Or is there somewhere in the classroom you could look? Maybe sometimes looking yourself at that is another little nudge, just a prompt. So you're not giving them really specific clues, but you're just starting to nudge them. That could be all they need to get started, particularly if this ability to get started by themselves is really hard and you're not quite there yet. Just a gentle prompt can be all it takes. Of course, it might need a bit more than that. And that's where you might go on to cluing. So being more specific, instead of saying, is there something that can help you? Maybe calling out a specific method that might be used. You might say, oh, could you use a number line? Or do you think the base 10 might help us here? Or could we act that out? So you're being a little bit more specific, still though using questioning. So what you're not saying is, let's use the base 10. You're asking the question. You're still giving the children the power here. It's them trying to encourage them to be more independent in their choices. Of course, that is still, and we've all been there, you've done your prompts, you've done your clues, you've given as many clues as you think you possibly can, and there still is a barrier to get any further. So this is where modelling might come in, and modelling is something that's used in maths all the time, and hopefully you're seeing your teachers do it all the time as well. But you working through a task yourself is a really good way of getting a child started on their own journey. Thinking aloud is the really important thing. So it's not very easy to do to start with, but try to get into the habit of having that. Speak out loud what you're doing. Oh, well, I'm going to put this here. Oh no, that's not quite working, so I'm going to move this over here, and I know that this is this, because constant commentary of what you're doing is really important, and not just a commentary, but also maybe keeping that conversation going. Oh, can you see what I've done here? Is there another way I could have done this? It's a two-way. It's not you doing it and the child just passively watching you. It's engaging them in that. Thinking aloud is really powerful, and also not just for you to do that, but to encourage children to do that as well. And if you're doing it, why wouldn't they copy? We know that modelling is a really effective method of teaching and supporting. So absolutely show, and not just show yourself getting a perfect answer first time, but show the struggles you might be having. Particularly if you've got a child who lacks confidence, or if you lack confidence, that's okay. That's okay for you not to be sure. In an ideal world, you would have seen the work that you're going to be doing with the child ahead of time. You might have had time to do it. I know that in one of the schools I was at, we had teacher books and TA books, and we had the activity sheets or the activity we were doing in there, and we did them ourselves first. However, I do know that is very time consuming and it might not work for you, but sometimes having it ahead, you can work through it and spot any things that might be tricky for you in explaining to the children as well. And this last one, we don't want to get to the point where you're correcting what the children have done, but we're being realistic in today's session and hopefully in the classroom, and we know that sometimes you might need to do that. And again, it's about keeping that positive spin, and you might correct, but you might correct maybe the first bit and then take a step back again, putting the independence very much in the hands of the learner rather than you as the educator. And as I said, I appreciate that's a very, very hard thing to do sometimes, depending on the area of maths you might be supporting, or the children you have in front of you, or just what's going on. Is it a windy day? Sometimes that can have an impact, can't it? So that's why this is very fluid. You're not going to say, well, you're going to do this every lesson, or there's only so much you can prepare for, because you don't know how the children are going to cope or react in a given situation. So we've talked about questioning a couple of times, and it really is a very powerful method in maths generally. So a little bit more about types of questions that you might use. You might use probing and clarifying questions. So questions like, are you sure? And don't just use are you sure if they got it wrong. I think sometimes children can think, if you're asking are you sure, oh, you've asked me are you sure, so maybe I've got this wrong, I'm going to have another look. Try and get into the habit of asking it often, even if they're correct, because actually they're able to accept, well, yes, I am sure, because that explanation shows a greater depth level of understanding. So it's a really good thing to do. Asking how do you know is another very similar question. And what do you notice? Maths is about noticing, being curious, and it's really important that we try to get that into maths as much as possible. Maths, despite what people may think, is actually a really creative subject, can be a really creative subject. Easy for me to say because maths is my favorite thing to do, but if you're a little bit less confident, sometimes asking what do you notice can be a bit scary, because you think, well, what if the children don't notice what I want them to? That's okay. We should be letting them notice anything, and then we can guide them in the right direction. So connecting and recalling questions, things like, if you know this, what else do you know? Well, if you know that 4 times 5 is 20, what else do you know? And that could be in the nature of what they're doing. That could be something they need to know for their task. So relating back to things that have gone before. We've talked about then maybe talking about things that in the classroom that could help, and that will completely depend on your setup, whether you have working walls, word maths jotters, which manipulative might help you. You know what you've got access to, but these sorts of open questions, starting open before you get more specific. And then encouraging and supporting. So have you seen something like this before? And again, you might need a second level of questioning if they haven't seen something like this before. So much happens in a classroom. Since their last lesson, they've had 4 other lessons. They might have had an after school club. They've had an evening at home. They might have had a club in the evening outside of school. They then come in the morning. Then some of them might have gone to breakfast club. They've had a break time. So many things have happened in the world of that child between last maths lesson and this one. And whilst we might be able to make that connection, for children that could be really hard. But it might just be you saying the question that might make them think, oh yeah, I do. And if you've got jotters, that's a really good thing as well, because they can refer back and look back. Oh yeah, that's what I did yesterday. I know this now. What does it remind you of? Do you remember when we did this? How might that help? I've mentioned jotters a couple of times, and I think they are a really good alternative to using individual whiteboards. Not just because when you take an individual whiteboard to the photocopier, you get ink all over the screen, and nobody likes that very much. But jottings are a way of recording what's happened, and it's not going anywhere. We had whiteboard books in my last setting, so that's where children, they weren't marked, and there was a very definite, you know what it looks like on here, as long as it's legible. What it looks like in here, it's not about this beautifully polished piece of maths work, it's about the thought processes that you're showing through this jotting. And again, really good to refer back to. So this is probably the trickiest bit, really, growth mindset and encouraging pupils to be more comfortable taking risks with their learning. And it's something we have to lead with example. We know that maths anxiety amongst adults and children is fairly high, and particularly in schools, actually. And so we need to make sure that we are modeling that, being comfortable with taking risks, as well as teaching children to do that as well. So thinking aloud, demonstrate that uncertainty. It's okay not to know, and then you can start a thinking process or a discussion to help push you in the right direction. So modeling that, you know, you're not expected to know all the answers to everything, so and that's okay. Embracing mistakes. Some children can get very, very bogged down if they make a mistake, and that can be the end of the task. Actually, in maths, mistakes are really important, and some of the best inventions were made through by mistakes. So mistakes, yeah, they definitely have a place. And you know, a maths strategies, trial and improvement, which is used often in maths, is about making a mistake or not quite getting it right, but then importantly analysing what's happened and making a better suggestion. So definitely frame mistakes as learning opportunities. Encouraging have a go. Those jotters that I've just mentioned, or whiteboards, whatever you have access to, it's low stakes. No one's going to look at it. And for some, actually, the whiteboard before the jotter might be what they need. Maybe they don't want their work permanently anywhere at the initial stage. Maybe they want to be able to rub it out. You know your children, whatever's going to support a have a go mentality. And then really make the risks as small as possible. Instead of looking at a whole task, look at one question. I think we've moved away in maths. Hopefully we've moved away in maths from having sheets and sheets of the same of calculations or mini activities, and we're spending much more time going deeper. It could just be taking one question. Let's take one question. That's all we have to do today, and then we've got a step. And sometimes that step is the first, and then that's all you needed. So just make the risks as small as possible so the confidence can be built upon gradually. It seems a good time to mention our absolutely amazing originals book. So the originals team created this gorgeous book, Mastering the Mountain. It's available as an ebook on the Twinkl website. You can search for it on there. And it follows a little girl on her journey through maths anxiety, and it sort of personifies that anxiety a little bit and talks about how that anxiety can be addressed. So it's a lovely read, just to have a read, but to share with children as well. It's a beautiful Key Stage 2 picture book, but certainly to prompt discussion and have that discussion. Maths anxiety is absolutely a real thing, and we need to be aware of it and talk about it. There's a lot of stigma around maybe not considering yourself a maths person, but having those conversations is a really good thing to do. And so that book might be something you might want to share with some of your pupils. So we talked at the beginning of the session about ensuring that we were being realistic here, and reactive adaptation, adapting in the moment is all very well, but what if you don't know what to do in the moment? We're saying, it's not as planned as traditional differentiation. You might not know exactly what your pupil is going to be doing, or your group of learners might be doing, but you can prepare. It might not be really, really strict like traditional planning, but you can be prepared. You can anticipate misconceptions. Hopefully, planning will be shared with you from your class teachers, and often now those misconceptions are built into planning, so you know the sorts of things that the children might fall into the trap of or make mistakes with. Consider existing barriers. You are the greatest experts in the children you're working with. So if you know that a child has a particular need or something that is just going to work for them, think about that before the lesson. And it could just be as straightforward as having an extra piece of paper to cover over the rest of the sheet, so you're just going to focus on one thing at a time. But again, you know your children. There's huge amounts of things you could do, but thinking about what the barriers might be for that child or that group of children. Creating a toolkit, so something for you that you can have easy reference. You know you need to do something, you've forgotten all those things you've learned because a lot has happened since then in your own lives. Having a toolkit can be a really good thing as well for you to refer to, and the sorts of things that might be on there are things that you can do quite easily in the moment. Adapting the language. We know we use lots of interesting words in maths, and it's really important that children hear and start using that ambitious vocabulary. But sometimes if a child doesn't understand a word, you have to, you might have to use different words until their understanding is increased. Explaining in a different way, so not just echoing exactly how the teacher explained it, but describing in a different way can be a way in for some children. And maybe not you explaining in a different way, but maybe you could encourage another child to do it as well. Providing a visual aid or using dual coding, that can be really, really good to do for all children. And we'll talk a little bit later about pictorial representations and their use in maths. We've talked already about suggesting an appropriate manipulative, clarifying the task. And again, if you could do it in a slightly different way to the way it's already been shared, that might be helpful too. Breaking a task up. So I've mentioned covering up the rest of the worksheet, so we're just focusing on one, but actually breaking a task down. Again, much easier for you as TAs if you have access to the activity sheets before the lesson. And if you have time to do that, that's great. Emphasizing key elements, highlighting, underlining, circling, just pulling out the things that are important and trying to get rid of any extra noise that maybe isn't so important but might be distracting. Setting an interim goal. So this is about, breaking down those risks a bit more, maybe just start small with what you're expecting. Providing a prompt, and that could be you as questioning, those prompting questions we talked about. It could be a maths mat, it could be a question on the working wall, could be something you've written on a whiteboard, just something that's going to just remind a little bit, nudge in the right direction. Providing worked examples, and the most beneficial use of a worked example is if you can do it live, but if not, worked examples often appear in planning and on activity sheets. So having that worked example so you can look at it is really helpful. And if your children have done that on whiteboards or in jotters, referring back to that. Allow for collaboration. A maths classroom, there is absolutely a place for everybody working independently and perhaps in silence or very quietly, but there is also absolutely a place for collaboration in maths. Some of the best mathematicians have discovered things together in groups. So if you are able to allow that discussion, and as I said, maybe sometimes a peer showing or re-explaining something can be easier for a child to understand. Using a STEM sentence or sentence stems, two quite different things. So a STEM sentence, we'll look at them in a bit more detail in a minute, or just starting the sentence for a child to give them a way to start a sentence. And those could be generic rather than just math specific as well. And using questioning, which we've already talked about. Now, we have created a resource which is handily lanyard sized with all of these things in that toolkit on, so you can really hopefully quickly just refer to them, because having that in your head along with all the other things you need in your heads can be quite tricky, but having it around your neck on your lanyard, really easy reference, hopefully be helpful. So we have created that resource for you too. I've mentioned a couple of times about how we might use models to scaffold understanding in maths, but I do always think in all of these sessions it's worth just mentioning it again. The CPA, or concrete pictorial abstract approach, is very common in maths classrooms now, hopefully in every classroom, and it's about starting with concrete resources or manipulatives to introduce key maths concepts, then moving towards pictorial representations, either given or creating your own eventually, and as a bridge to understanding the more abstract. We know that maths can be very abstract. So for example, you might start by, if you're looking at maybe number bonds within 10, you might start with a tens frame with two double-sided counters and having 3 orange and 7 teal, for example. You then might move on to having that a static image like it is on the screen now, or drawing your own, or colouring your own, whatever would work for the age of children you're working with. And eventually what you're working towards is something like this, a very abstract missing number problem, but we're thinking about stepping stones towards understanding that abstract, and that understanding, that conceptual understanding, is so important. Because it's called the CPA approach, I think often there's a misunderstanding that we start with concrete and then we get rid of the concrete and move on to the pictorial, and then we move that out the way and move on to the abstract. But actually it's important that we don't see it as that. Really, if you're going to use, I've been in classrooms where children have been very confident using counters for addition, but there has to come a point, we're talking about this scaffolding, where you remove that and you move along to a picture or a representation, and then you move to abstract. And one of the best ways to do that is to use them alongside each other. So you would have the concrete alongside the pictorial, and then you'd gradually fade out the concrete and move towards the abstract. Of course, sometimes you may have to go back as well. It's not just one straight journey. It might not fit everything. But so just bearing in mind that that CPA approach isn't always going to work in a very neat straight line from one to the other. And just a reminder really of the things you might use. I mean, hopefully these are the things that you have in your classroom, but base 10, place value counters, coins, bundles of straws, rec and recs if you're lucky enough to have them. And then those things should move to a representation of those things in part whole models or bar models, number lines, things like that. And then eventually, of course, moving to more complex abstract algorithms. STEM sentences are wonderful for reinforcing vocabulary, and they're vital really in when you're teaching new concepts. So it might start with, if you look at that top example on the green there, you might start with a sentence that's been filled in for you, and you'll notice that some of those bits are bold. Those are the changeable pieces. So you've got the whole sentence or sentences, and in the best lessons, sometimes you might say them, you're actually vocally saying STEM sentences. You might say them as educators, the children might repeat them, you might do it chorally, but you're practicing the sentence. You're giving children that STEM for them to start being more independent with their maths talk. We know that talk is obviously is really important in maths. So you start with a completed sentence. You might do a few of those using examples, and eventually you're going to remove those bold bits, those changeable pieces, into a space which can be filled in to suit a different example. It comes with practice. It's not going to be very, very straightforward straight away, but definitely worth looking into how you can use STEM sentences to support that communication with the children. Always, again, as I said with the Mastering the Mountain book, it's always worth talking about the power of a good story in maths, and we've been talking about this a lot at Twinkl recently, so wanted to share this with you, some of these fabulous images of how books have been used to support maths, and they don't necessarily have to be specifically maths books. Most stories you can find some maths in, so absolutely a really great opportunity to support that really important oracy that we've been talking about, in using a story to make something a little bit more concrete. And there's just some examples of how some of our lovely originals stories have been used to support maths, and there's some links on the slides for you as well if you want to explore that further. So that brings us to the end of today's session. There is an awful lot covered in the session. Adaptive teaching is difficult because you are reacting in the moment. You are being prepared rather than being totally planned in a traditional sense, and it can be easier said than done. But the fact that you are here this evening and you are wanting to learn a little bit more about adaptive teaching hopefully means that you can see the power of it and are willing to hopefully bring some new things into your classroom. So before we finish, just a little thinking point here. Hopefully there are lots of things, but just thinking, what is one thing that we've covered today that you'll be able to take into the classroom tomorrow? Maybe it's the lanyard. You're going to print that out and use that. Maybe you're going to be thinking about your questioning going forward. Just one little thing as a little reflection. And if maths is what's interesting to you and you want to hear more about what we're doing in maths or what's happening in maths, you please do give us a listen on the Primary Maths podcast. There's a link there on the slide, often talking about things that are happening in the primary maths classroom, so definitely worth a listen. And I'd just like to take this opportunity to thank you once again for giving up your precious time to come along this evening. Hopefully it has been useful for you. Thank you again to the TA team for inviting me along. It's always a pleasure, and to our TeachMeet team for facilitating. I wish you all have a lovely evening. Thank you very much.